Hello class 2 students. So it is a continuation of your magnification that last I taught you. What is magnification? It is the ratio of height of image by height of object. Now by looking the value, how will you understand about your image? So now first one I am showing you. First case here, if your m is positive, that means your hi and h1 both are positive value. The value is positive, it is both are positive. At which condition both are positive? That means in that condition both are will be upright, because you know that above your principal axis it is plus. If you go above your principal axis it is plus. If it is both are positive, that is which case possible? That means if it is positive, when it is coming, it should come in back side of which one? It will come back side of your mirror. That means it will be erect, your image will be erect, it will be virtual. Clear? Your image will be erect and it will be virtual. Now if what will happen if m is negative? If m is negative, in that case your height of image by height of image by height of object is negative. In that case object will be above your principal axis and image will be below. Clear? So object will be above the principal axis, image will be below. In that case it is erect, it will be inverted. Your image will be inverted image as well as it will be real. Clear? So by looking m is positive or m is negative, we can find two conclusions. Clear? Another way is whether the value of m mod m is greater than 1 or less than 1. What do you mean by greater than 1? You know, again, height of image by height of object, it will be greater than 1. That means your height of the image will be greater than the height of the object. That means you can tell is it is what? It is magnified. Same to same, if it is less than, what do you know? Height of image by height of object is less than 1. That means your height of object will be less than height, image will be less than object. That means it is diminished. Clear? That means by looking the value whether it is positive or negative, you can find this conclusion. Again, by looking the value whether it is greater than 1 or less than 1, you can find out your conclusion again with this magnified or it is diminished. Clear? Now very important topic I am going to teach, that is mirror formula. That is mirror formula. After that, there is a very important topic for you. Let's see for mirror formula. That means mirror formula. You already know what is the mirror formula. Mirror formula 1 by f equal to 1 by u plus 1 by v, that I am going to use. What is f? F is focal length or length of focus, u is distance of object and v is distance of image. Clear? So what is your mirror formula? 1 by f equal to 1 by u by 1 plus 1 by v, where f is the focal length, u is distance of object and v is distance of image. Clear? So let's prove it. So you can draw one. Let's, for concave lens we will do. Okay. So here is your focus. See, now consider here is an object. So what do you know? Center means it will be always perpendicular. That is a normal we can draw. Clear? It is perpendicular. We can draw one normal. Now from here at an angle theta. Okay. So after the reflection. After reflection, it is going through. Okay, it's making another angle It is point. Or little bit neatly you can draw the diagram. Okay. So by snapshot you know this one is theta, this sorry the law of reflection you know this one is theta, this one also theta. Clear? Now another thing we know that F equal to which one? R by 2. This one already you proved in previous class. Now if I consider this angle is alpha, this angle is beta, and this one is gamma. Clear? Now see this one is P, optical center. Now if I draw one perpendicular here, it means P dash, this will be height. As we know before also I told in our study, this aperture is too small. When the aperture is too small, that is the aperture will be too small. In that case, if you draw a perpendicular, that means almost same. Almost same. If your aperture is very too small for a curved mirror, the distance between P and P dash is too small. That means I can consider it is same only. Clear? Now from here to here, the distance I can consider as distance of object minus u. Now by using this formula, the here to here, it is coming here, this one we can consider as u distance of image. Clear? Now we can consider one ray light is going there, it is coming in that way, another light ray is going there straight, again coming back, so there it is your image where it is forming. Clear? So this is your image minus v. Now see here, if you consider this triangle, what is your tan alpha? Tan alpha is perpendicular by base. That means your perpendicular how much? H. What is your base? Base is minus u. Same to same you can find tan beta h by, if I consider this one is h. What is tan beta? This one is r, radius of curvature, r. Now if you consider this triangle, what is your tan gamma? Tan gamma is h by how much? Minus v. H by minus v. This is the relation. Clear? So from triangle we can find out. Another thing, as I told, aperture is too small. As aperture is too small, what we can write? We can write tan alpha equal to alpha, tan beta equal to beta, and tan gamma also we can put as a gamma. That means this one we can write as a alpha, this one I can write as a beta, this value we can write as a gamma. Now see, in a triangle we know that before in smaller classes we learn, if it is a triangle, if sum of inside angle is equal to the outer angle. If it is A, B, C, you can write C equal to A plus B. Same to same, here you are having one triangle. If I consider the triangle, which one? This one is theta, this one is alpha, and this one is beta. Now from here what you can write? Beta equal to alpha plus theta, equation 1. Another triangle if you consider, that is N, O, C, another N, C and F. This is again theta, this one is beta, and this one is gamma. That means you can write gamma equal to beta plus theta, equation 2. Correct? Can you find any relation between them? Just minus this. If you minus this, you can get beta minus gamma. This one will be minus, minus cancel. You can get here alpha minus beta. Clear? Now I can bring this on this side and this one in this side. Then you can write. If you bring here, is there a relation? Yes, we can write beta plus beta equal to alpha plus gamma. That means 2 beta equal to alpha plus gamma. So beta equal to alpha plus gamma by 2. Now if you apply these values here, what will happen? What do you know about the values? Let's see if we apply the value. Now if we apply the value, after that, see here, if you apply the value of, what is the value of beta? Beta is What is the value of beta? Beta is h by minus r equal to alpha value. Alpha is h by minus u plus gamma value h by minus v, clear, by 2. Now if this 2 you take here, it will become minus 2 by minus r, all the h you can get cancelled, you will get here 1 by minus u minus 1 by minus v. If you omit all the minus, this all the minus, if you omit, what you will get? 2 by r, or this 2 you can take down, 1 by r by 2 equal to 1 by u plus 1 by v. Now that time also I shown what is the value of r by 2? R by 2 value is f. So it will become 1 by f equal to 1 by u plus 1 by v. That means after from this line, you need to start from here. Clear? So for mirror formula is 1 by f equal to 1 by u plus 1 by v. Clear? So same one you can try, that is a given, I will give you homework, you can try for convex lens. Okay, you have to prove it and to show me, you have to try for the convex lens. I have done for concave lens. Clear? Okay. Now the last topic, little bit topic is there, velocity. Clear? Now for plane mirror also you find the velocity. Now we can find the velocity. Okay. Now see, if it is your mirror, again I am going to for concave non. Now what is the formula? Formula is 1 by f equal to 1 by u plus 1 by v. I am going to find the velocity. That means how much if one object is moving, how which one will move? Your image will move. Now here, first of all, your mirror is in rest. Your mirror is in rest. Let's see. Now remember, focus length, focal or for everything, focal is for each mirror is constant. This f is always constant. Your focus is always constant. Now if you differentiate, all you can write 1 by f, you can write f to the power minus 1, you know, f to the power minus 1 by u, you can write u to the power minus 1, and v you write v to the power minus 1. Now if you differentiate this one, it is a constant value, its value will become 0. This one if you differentiate, d by dt of u to the power minus 1 plus d by dt of v to the power minus 1. Now you know x to the power minus n formula. What is x to the power minus n formula? ddx of x to the power n formula is n into x to the power n minus 1. This formula I am going to use here. Clear? So 0 equal to, what is your n? N is your minus 1 into u to the power minus 2. Minus 1 will become minus 2, and you will get here du by dt. Same to same here, minus 1 into v to the power minus 2 dv by dt. Clear? Now if you bring this one this side, what will happen? It will become 1 by u square du by dt. Why u square? Because u to the power minus 1 equal to, this minus will be there, 1 by v square dv by dt. Now from here, what is du by dt? This u square will go there, minus u square by v square dv by dt. So as we know that u is a distance, so distance differentiation will give you velocity of object equal to minus u square by v square velocity of image. Clear? So what is the condition here? Your mirror is in rest condition. Now if your mirror is also moving, with respect to the mirror also moving, we know that last time we write here v0 minus vm, that is the velocity, equal to minus u square by v square, and here we will find vi minus vm. So this is for your last topic for mirror part. Clear? So you can find out your velocity. Some other numerical also will be there, we will discuss later. So this part you complete. Okay? Thank you.